Today we're going to learn some more trig identities, another technique to prove trig identities, and practice a little bit more. So the next category of trig identities are the cofunction identities. And it tells us that sine of A is equal to cosine of 90 minus A. Now let's take a look at this a minute. We have our triangle labeled in the standard way where I have my sides opposite my vertices named with the lowercase letter. So let's look at sine of A. Remember, sine is opposite over hypotenuse, so sine of A would be A over C. I'm going to write this in here. And then cosine of 90 minus A. Remember that the acute angles of a right triangle are complementary. So the measure of angle B would be 90 minus A. So cosine of 90 minus A is adjacent over hypotenuse. This is the adjacent side to this angle, A over C. And you can see that sine of A is definitely equal to cosine of 90 minus A. Now take into consideration these measurements are in degrees. We can also write the same identity using radians. So sine of A is equal to cosine of pi over 2 minus A. So that's how you prove that sine and cosine are cofunctions. You can write it either this way or that way. Tangent and cotangent are also cofunctions for the similar reason here. I'll leave that to you to prove. And secant of A is equal to cosecant of 90 minus A. Now, remember, we can equally show this using radians. So it all depends on what measure your angle is in. Now I'd like to prove this next identity using a new technique called multiplying by the conjugate. And this is how this works. I'm going to work on the left-hand side, and I'm going to multiply by 1 plus cosine of x over 1 plus cosine of x. That's the conjugate for that denominator. And I'll explain why I'm doing this in a moment. So I would get secant of x times the quantity 1 plus cosine of x. And in my denominator, I get 1 minus cosine squared x. Now, think back. There is an identity here. It's a Pythagorean identity. You need to be able to recognize that Pythagorean identity in any of its forms. So this is the one I'm talking about. Sine squared x equals 1 minus cosine squared x. Well, that's just the denominator here. And now I can rewrite this as sine squared x, which is very helpful because that's what I'm looking for on my right-hand side. So I'd get secant of x times the quantity 1 plus cosine of x all over sine squared x. Now I'm looking to rewrite this numerator as secant of x plus 1. Let's see what we can do here. So I'm going to distribute secant of x. That gives me secant of x plus secant of x times cosine of x all over sine squared x. Now, we always look from where we are to the other side to compare. Now I'm getting really close here. This is secant of x. I need this to be plus 1. Oh, look at secant of x and cosine of x are reciprocals of each other. So I'm going to write this as secant of x plus secant of x times 1 over secant of x. That's all over sine squared x. And here is my desired result. So let's think back to why I chose to multiply by the conjugate. Well, I knew I needed to rewrite 1 minus cosine of x somehow to get sine squared of x in my denominator. Because I've done this before, I know that if I multiply 1 minus cosine of x by 1 plus cosine of x, I'm going to get this Pythagorean identity that will allow me to make the shift. So you need to watch for situations like this. The next category of identities are the sum and difference identities. And you can see there are sum and difference identities for sine, sum and difference identities for cosine, and also for tangent. They all look remarkably similar. If I look at the sine sum identity, it looks exactly like the difference identity, except for one is plus and one is minus. Same is true for the cosine identity. They look remarkably similar. One's minus, one's plus. And same for tangent, very similar, except the signs are different. For those of you who are asking for a proof of these identities, there are some exercises in our book where the proof is shown. Now, we do need to remember these identities, and luckily, I came across a nonsense kind of story at a conference that can help you remember. Let's take a look at that. So, this is the story of Sinbad and Cosette. Sinbad loved Cosette, but Cosette did not feel the same way about Sinbad. Naturally, when Sinbad was in charge of their double date, he put himself with Cosette and he put his brother with her sister. So here we're looking, Sinbad is in charge. He put himself with Cosette and his brother with her sister. Sinbad loved to tell people that his and Cosette's signs were the same. Look at plus, plus, minus, minus. Sinbad is matched with Cosette. However, when Cosette was in charge of the double date, she placed herself with her sister and put Sinbad with his brother. She made sure everyone knew that their signs were not the same. Cosine, the sum identity here, plus, opposite, minus, difference identity, negative, plus. Also notice that Cosette placed herself and her sister before Sinbad and his brother. This detail was important to Cosette. She was very snobby, you know. Well, look at the reason that detail is important is because it's cosine of A times cosine of B minus sine of A times sine of B. And you really do need to know these identities as well. Here's the next category of double identities. I have sine of 2x equals 2 sine of x cosine of x. There are 3 double angle identities for cosine and 1 for tangent. These are all really important, and yes, you do need to memorize them and know them. So let's take a minute and prove the double angle identity for sine. Now, normally, general rule of thumb is that we work on the more complicated side. However, this is one of the cases where that does not work. So I'm going to work on the left side. And I'm going to rewrite sine of 2x as sine of x plus x. And I'm going to do that because I'm going to use the sum identity for sine, which is this. Now I'm going to substitute into sine of x plus x. X is A and x is also B. So this becomes sine of x cosine of x plus cosine of x sine of x. Now I have like terms. This is 2 sine of x cosine of x. And we get the desired result. Next, I'm going to prove this identity. Our general rule of thumb is that we start on the more complex side. I'm going to do that. And the key here is that we are aiming to rewrite the right to be sine of 2x. So it's helpful to keep in mind what that identity is for sine of 2x. I know sine of 2x is 2 sine of x cosine of x. So as I am working on the right side, I would like to rewrite this so that it looks like that. Now you'll notice that everything on the left-hand side is in terms of sines and cosines. So I'm going to rewrite all of this to be in terms of sine and cosine and simplify. So I know that cotangent is cosine over sine. So I'm going to make that substitution. And now I'm going to get a common denominator in my denominator and add these two together. So the common denominator here is sine squared x. So let's rewrite that. Now remember I said that every single line that we write in an identity proof is exactly equal to the one before. So I have to rewrite the whole thing. And this is my favorite identity, the Pythagorean identity. Seeing that, I know that is 1, so I'm going to make that substitution. And now I'm going to divide. So when I divide, I multiply by the reciprocal of my divisor, and this becomes 2 cosine of x over sine of x times sine squared x over 1. Now, that means one of the signs here cancels with one up there, and this is equal to 2 sine of x cosine of x. Yay! I finally got where I wanted to go. So now I recognize 2 sine of x times cosine of x is sine of 2x. And I get my desired result. The other thing I want to point out here is if you ever get stuck, there is a map for you to go the opposite direction. So if I were stuck on my right-hand side, really, you can prove the left side just by working backwards. So let me change colors here so you see what I mean. So if you get stuck, you can start to work on the opposite side because it will serve as a path to finish. So if I wanted to see how this would be proven on the left, I would just work backwards. This is sine of 2x. So the next step would be 2 sine of x cosine of x. The step before that would be this. That's 2 cosine of x over sine of x times sine squared x over 1. Now, I'll admit, I would never think of doing it this way. But from one line to the next, it absolutely is a true statement. I would continue to work backwards. So this is equal to that. So that gives me 2 cosine of x over sine of x all over 1 over sine squared x. Continuing to work backwards. This would be next. So I'd have 2 cosine of x over sine of x all over sine squared x plus cosine squared x all over sine squared x. So now that brings me here. I have one more step to get here. So I would rewrite this by splitting this bottom fraction up into 2 parts. So now I have 2 cosine of x over sine of x all over sine squared x over sine squared x plus cosine squared x over sine squared x. So now I can recognize 2 cosine of x over sine of x is 2 cotangent of x, and the bottom would be 1 plus cotangent squared x. So the reason I wanted to show you this is because I want you to understand, if you get stuck somewhere in here, you can always switch to the other side and meet in the middle, and it will give you a path to finishing your proof. You must start your proof on one side and finish on the other side, but you can use that other side to figure out how to finish. So, and usually there is one method that's more intuitive than the other. In this case here, I would never think to go from this step to this. As I said before, I am really good at proving trig identities, and I'm good at that because I have done a lot of proofs. So practice makes perfect. I want you to work on the assignment that I've posted online. Have a great day.